Okay, last week we are talking about test of the two populations mean, right? And there will be three methods. First, one sample t-test, independent sample t-test, and the dependent t-test, right? And last week we already finished the independent t-test. So today we continue last week the dependent sample t-test. Okay. When we have to do dependent sample t-test, please remember about this paragraph. First, if you want to compare the average value before and after some event, what is a before and after event? For example, before an English language training, our English score may be very low, right? For example, maybe the average, our English score may be only 45, okay? Point, very low. So the school hire an English teacher to come to teach us the English, right? So all of you accept maybe a period of the English training, right? English training, right? Then your score from 45 up to maybe rise to 85. So before and after. Before and after one kind of event. What is the event? English training. Right? A training. We will compare before this event. If the here is significantly different from before, that means the training is effective, right? For example, we usually deploy the artificial reef. We usually deploy some artificial reef. For example, artificial reef here. We usually install or drop some artificial reef. This is made by salmon, okay? To enhance the fishery resources, to attract the fish come here, and the hatching and the grows up here. So, if you want to evaluate or investigate, make some research on the efficiency of the artificial reef, you can do in a fishing operation. Before deploy the artificial reef, the CPUE, catch per unit effort, you can catch the CPUE. CPUE is equal to catch per effort. You doing the fish operation here, maybe 1 hour, you got how much catch? For example, before your CPU may be 10 kilogram per hour. But when we deploy the artificially, it attracts a lot of fish here. So enhance the fish resources. So after, maybe you come here to fish again, or you will get a lot of fish because they're attracting a lot of fish. The fish resources is abundant. So maybe you got a 30 kilogram HR. So if you want to compare something before and after, you have to do dependent sample t-test, 2 group, okay? The other condition is if you want to compare the same group of people, what is the same group of people? For example, some patient in the hospital, yeah? One group of patients, maybe they take some medicine, take some drug. Maybe group 2 is the same, the patient, but they take the other medicine. Yeah, also 1, 1, 1, 1, 2, 2, 1, 2, and pair 1 by 1. Under this condition, we have to using the dependent sample t-test. Okay. Same people, same thing. Yeah, same people. For example, before I give you the English training, you only have only have 6 person. But after training, you are 6 person. Okay, same person, same thing, same place. Okay. Very typical example. Oh, sorry. Are 12 young men participating in the English training, right? Before their scores, after their score, right? So if you want to know the training, the English training is effective or not, or you have to do dependent t-test, okay? So please open the SPSS. There's data, okay? Open the data, okay? From your USB. Okay, chapter 2. Here's chapter 2. Okay, here, B train, A train. B train means before training your English score. A train before after training. Okay, So we doing the analyze compare means pair sample t-test, okay? And we put, remember, if you put the variable here for variable 1, okay, and the other, for example, A trend to the variable 2, the t value is equal to x1 bar minus x2 bar. So here, this is before. This is after, okay? If you change the two value, you will change, okay? Yeah. So if you get promote of your English, you can imagine the t value will be a negative value. Why? Because it grows. Your score is promote, right? So after the training, your score is higher than before. So the t value at the last, you got the t will be negative value. Don't worry about seeing the negative value, okay? And then we click the OK button, and we got this. And you will see here, t where's the that result as this one. Yeah, today he's unhappy. Maybe. Okay, as you can see here, t is minus 4.518, right? Minus, just as I told you, because the formula of the t value is that x1 bar minus x2 bar. This is before, this is after, because your score is promoted. So before minus after will be a negative value. Don't worry. If you think a negative value, don't worry. That is good. You have to be happy because your English, yeah. Okay. 可以了吗？怎么又变大了？ The t value is equal to my. Today maybe he's unhappy because I have fight with. Since the t value is equal to minus 4.518, so and the p value is 0.001. It's very small. Then the criteria value 0.01, right? So we keep 2 star. Very, very significant difference, okay? So we accept the H1 anti-hypothesis is accepted. That means there is a significant difference before and after training for the 12 young people for their English score. That means the English training is effective, right? So someday if you want to teach English, maybe you can make a test like that. And you got someday you make the student their scores promoted. You also can use this for your promotion. Yeah, you can use it for, sometimes you go into the cramming school in the United States. Some people come to Taiwan also teach English at the cramming school. How can you prove? Yeah, that's here. Yeah, right. Yeah, I teach at some senior high school or junior high school, their English program. But two sides, lower. Confused. You confuse one condition, you use one way. What condition you have to use 2 way, right? Yeah. Compare, it's only one way. Yeah. How can you do it? Because the software is already programmed by the programmer. You cannot change, right? You mean here is always a two way, right? To tell, right? You cannot change, right? Don't worry. You just, this is the t value, probability, p value, you understand? 0.001, this value is calculated from your data. You understand? So, no matter what, this is 2 way. This is 1 way, okay? We always take alpha as 0.05, right? If you define your research as 2 way, so here will be 0.02, I mean 2.5%, okay? If you demand your research alpha here, so it will be 5%. But your result is 0.001. No matter what here or here, they're always very, very small. Right? You understand? This value is your p value. Okay? Very, very, regardless, 1 way or 2 way, this value is very small than alpha or even alpha divided by 2. You understand? p-value. P-value 0.001 is mean how much? You are the 100%, the very, very top. You are the top 0.1%. For example, here is 1%, okay? You are this one. There are 99% people is lower than you. There are 99.9% is lower than you. 0.1 top. So it's very, very small. You understand? Even you use the one tail alpha is 0.5. Here is 0.5. Here maybe 0.25. But you always up you are up then the 0.5 or even the 0.25. You are very small. This is a P. Maybe I can give you an example. This condition, if this condition happen, the probability of this condition happen will be 0.001. If there happen this condition, the probability will be, it's very, very small, but it happened. That means what? That means it really significantly. You understand? The probability is very low, but it happened. So that means your sample is very, very significantly, you're up to the significantly level. So we can use the caricature of our sample to interfere the population. We can use the result to interfere the population. It can represent. It can replace. No problem. Right? Make sure, very, very sure, no problem. Okay? Because the p-value is very small, even you choose one side or two sides, because one side, the alpha, two sides, the alpha is 2.5%, but your p is 0.1%. It's very lower than this. Even one side is even lower. So that means it's very, very significantly. No relative. Yeah. Okay. Just remember, this is the p-value. Okay. Okay. Actually, I have some homework for you last week, but because the time is short, so I didn't give you the homework. Maybe today I will give you the homework after our class. Okay. Okay. Up to now, we just mentioned about if you want to compare two mean from two populations, you have to use the t-test. And the t-test includes three conditions. One sample t-test, two samples. Oh, no, sorry. Independent sample and the dependent sample, okay? Now, today we will continue if we want to compare the average or the mean from 3 or more than 3 population, what method we have to use? ANOVA, okay? ANOVA is coming from analysis of variance, okay? ANOVA, okay, variance. We just capture the brief of the vocabulary, analysis of variance. But usually, when you are undergraduate university, or you're reading from some textbook, you will find ANOVA have many names. One-way ANOVA, two-way ANOVA, one univariate ANOVA, multivariate ANOVA. ANOVA. What kind is ANOVA? Like sometimes it will confuse you. Actually, it's very simple. But why you always confused? Because this is the strategy of a teacher. Why? The teacher always confuses you, so making it is very great. You understand? Yeah. Actually, very, very simple. No matter what one-way ANOVA, two-way ANOVA, or univariate ANOVA, or multivariate ANOVA, they are all ANOVA. Okay? Human is human, cannot change. Okay, this is what we always collect the data, right? In our concept, we always define x be independent variable. We always say x be independent variable, right? Y is dependent. Variable. We always say that, right? And we always analyze how the x will influence. How to affect. How to affect this, right? For example, the methodologies of teaching skill. The methodology of teaching skill will affect the mathematics score of senior high school student. The teaching skill maybe it will affect your score. I don't know the teaching skill or in your memory. When I was a child, my teacher always teach us mathematics with what? With a rod. This one. You understand? What? Math. If you got 100, good. You should. But if you got 99, you have to be punished one slide. You ever been Have this experience? No? Oh, you are so lucky. I'm so very unlucky. So if you got 0, oh my God, you will cry. Here we are explore. Oh my God, cannot sit. This is one kind of the punishment skill. Always punish. Yeah. Here you got 100. Perfect. So my mathematics is by punishment. Always. You ever got it? You have the experience of this? And do you want to teach a student with this? Punishment? No. When I grow up to senior high school, Taiwanese teaching skill change. Everything is for loving. We say love teacher. Oh, you got 100. You are talent, genius, very good. But if you got 99, only one. You got 100, very good. I give you a sugar. That's sweet. Yeah. Oh, if you got 0, oh, good. Congratulations, your child is a genius. There are still 100 get promoted. So you also work hard, okay? This is love in teaching. But now, we have up to now, especially in university for me, yeah, I don't use the punishment teaching. I don't use the loving teaching. I use what? How to say that? No matter what. I don't care. I don't know how to say that word vocabulary. Just no matter. I just come here teach my class. I just told you what is the statistic. I don't care you will get promoted or not. That is no relationship to me. Yeah, we don't have any feeling. We don't have any relationship. Yeah, it's very cruel. Cruel, If you want to compare 1, 2, 3, this is teaching skill. Teaching skill will influence your score. Teaching skill is independent variable. Your score is dependent variable, right? Okay. If your research, please listen carefully. If your research is focused on independent variable, you want to discuss what kind of the teaching skill is better. Your research is focused on here. We call that is way ANOVA. Way actually is methodology, okay? If you just focus on what kind of the teaching skill will affect the student score, we are researching about a teaching skill, right? One way, one factor, one factor to affect the score, one factor. So we call that one-way ANOVA. But sometimes you say, the teacher's teaching skill will affect your score. But maybe the equipment, just like this, will also affect your score. Because right now you sit at this class. We have the fan, we have the air conditioner, we have the PPT, right? You have the my teaching you have the my PPT file, right? So it's very convenient for you, right? But if someday we go to the playing ground under the sunshine, oh, it's very hard, right? You cannot sit there. So maybe you're thinking the environmental factor also will affect your score, right? So if you're thinking not only the teaching skill, but also there have another environmental factor will affect your score. So we call that two-way ANOVA. You understand? Oh, maybe you are thinking not only the teaching skill, but also the environmental, but also the textbook. You use the older version textbook and the new version textbook, maybe newer version textbook, they will include more new knowledge. So maybe your score, maybe you were higher than you use the old version textbook. Understand? So the material will maybe will be the other factor that will affect your score, right? So if you want to investigate how many factors will affect your dependent variable, up to 3, we call that multi-way. So way ANOVA is you are focused on the dependent variable. You understand? But if you want to research or assessment about the dependent variable, the result, this is the result, right? This is the factor. Your study is focused on here. That is what we call Bayes rate ANOVA. Bayes rate. B-A-R-I-A-T-E. Bayes rate ANOVA. When I see Bayes rate ANOVA, oh, I know you are research study about the dependent variable. For example, I give you a new fertilizer to feed the plant, right? The fruit, okay? Oh, I want to see the sweetness will improve or not. I give you a new fertilizer. Right? I plant 3 fruit. Maybe first is the apple. Second is pineapple. The third is wax apple. Apple, no problem. Pineapple, no problem. What is wax apple? You understand? Uncle, you know what is a wax apple? Sorry. This is a wax apple. Okay. Okay. I use only one fertilizer, but I feed 3 kinds of the fruit. And I want to get the sweetness where more sweet, better than before. I want to know the result is better or not. So I focus on the dependent. I focus on the result. This ANOVA, we call that bear rate ANOVA. Understand? I'm the teacher. I always punish the student. I'm very scared on punishing the student. Okay, only my teaching skill only punish. Okay, when I have the class of the mathematics, I use the punish. Is effective? Or I go to another class. I teach English. I always pass. And I go to another class. I teach English, mathematics, English, Chinese. Okay. I want to know what kind of the class, Chinese, English, or mathematics, will be affected by my skill. Oh, if you punish the student for their mathematics, they will promote very good. Oh, okay. So you can suggest the president. You can hire some teacher to when they're teaching the mathematics. You always punish, they will get promotion, right? You want to know the very result. That is the bear rate, and the bear rate includes univariate ANOVA, multivariate ANOVA. Okay, actually, one way ANOVA, you are talking about 1x. Two-way ANOVA, you are studying about 2x. Multi-way is studying about xn, right? Univariate, you only got one result. Multivariate, 2 or 2 more than 2. But they are all ANOVA, okay? Sometimes we call this MANOVA. Okay, I already finished the ANOVA. One factor, but include many methods. You understand? One factor, only one factor. Teaching skill, but I have many teaching skill, about 3 or 4, 5, 6, I have many skill. But this all this skill, we told that the teaching skill factor, one factor. Okay? For example, environment in the air conditioned school room, in the training ground, yeah, in the pool, right? Yeah, understand? Yeah. Or even you can include the third factor. The third factor includes textbook, the newer, the older, right? So you have the very clear concept about this, okay? If you have the very clear about this, ANOVA is finished. It's very easy. Let's talk about this chapter 3, okay? I will ask the Miss Sari to put the chapter 3 PPT and on the platform of the, sorry. Okay, I will read this, okay? What? Yeah. If someday you get rich, please donate some money for the school, please. Okay. Okay, just this is I already tell you. ANOVA, the types of ANOVA. Okay, I can. The types of ANOVA, we include two. One is weight ANOVA, the other is variate ANOVA. Variate ANOVA include univariate ANOVA. That means we just want to search about the Y1. Multivariate ANOVA, sometimes we call that MANOVA. MANOVA is what we want to study about the result of the dependent variable. Dependent variable included more than two dependent variables. That is MANOVA. Way ANOVA, we are searching about the factor. Which method will be the better? Okay. Yeah, that is what way ANOVA. One way, two way, multi-way. That's okay. But just as I mentioned about, when we comparing the mean of the population, we have also three conditions. One is one sample. The other is independent sample. The third is a dependent sample. Okay? ANOVA have one sample independent or dependent sample. Yes. Yes, also. ANOVA analysis also have one sample ANOVA, independent ANOVA, dependent ANOVA. We have also three kinds. For example, I give you the example. Okay, let me read about this. Let me read about it. The univariate ANOVA is a statistical method that analyzes only one dependent. One way, right? So they analyze only one dependent variable, okay? Yeah. Two is analyze two. Three or more than three is multi-way, okay? I think I already taught you, so I don't need to read it again. You go home, you read it, okay? Yeah. Okay, I give you one sample ANOVA, okay? One sample ANOVA. Here. If we have data from 10 adults, we measure their IQ, yeah, their intelligence scale. Okay, we use the Westman adult intelligence scale. Okay, 10%. This scale includes language scale and the homework scale. That means they are testing your language ability and assignment ability. Okay. As we know, the human, most of the people, their language scale is 60, but their homework scale is 50. This is the general value. I mean, most of the people, if I give you a language scale test, maybe you got 60, the average value. Okay? Now, I have the newer student. Maybe I have the 10 student. Okay? I give them the language scale test and the homework scale test. Is there any difference between the students and the general person? The general person, their score in English scale is 60. In homework is 50. So this is my result, my data. I want to compare with the one criteria value, one standardized value. Okay? How to do that? Okay, we have to establish the hypothesis. First is this. The second is this. Language for homework. Okay. Our hypothesis, neural hypothesis, we suppose the adult score of each person on the language is not significantly different from 60. Yeah, that means this 10% is similar or the same as general person, right? Same. You are not Terran. You are not so strange. You just similar as that. The anti-hypothesis is significantly different. Okay, that is very easy to establish the hypothesis. Yeah, I think you already get used to doing that, right? But how to analyze this? Please open your SPSS. I'm sorry, I already. If you want to work with me, you can key in here this data, okay? Language, homework. But if you want to practice after class, I will ask the Miss Sari to put the data for you, okay? You go home to practice, okay? But here I will explain and doing the process. Okay. This is the language score for the 10%. This is the homework score for the 10%. As we know, the average language scale is 60. Okay. The 10% score we are compare with the 60, right? So first we have to do in a transfer. Remember, we have to do in the transfer, okay? Transfer what? Because we want to compare the 10 persons score with the 60, right? In language. So we use their score minus 60. Then we got a result. First one, minus 60. First two, minus 60. And the last, the 10th, minus 60, we got the 10. We use this. This is what we call deviation. Deviation. We use this deviation to do in the ANOVA, okay? So we got that. First, we do in the transform. We compute the variable here. We do in the transform, we compute the variable. Then we define a target variable for D1, deviation 1. Deviation 1 is equal to language score minus 60. Okay? Then okay. So we got a D1. Where? Here, okay? And then we define the second. We define a transform. We compute the variable. We define D2 is equal to homework score minus 50. Okay, because of the 50 is the average value for the general person. Okay, so we use this. Then we got the okay. Yep. All right. Any question? For example, I have a D, so I use another. Okay, SD. SD language, okay. Then I use the SD2 as the minus 50, okay? So I have the two deviation. One is SD1, one is SD1. One is SD1, the other is SD2. Minus 6 is the 45 minus 60, so it's minus. Yeah, understand? Positive. Because the first one, because the first one is 54, so minus 60 is minus 6, okay? That's okay. Yeah, so we use these two variables. The new variable we doing the analysis. But remember, this is result. This is the result. So this is what we call better rate. Better rate. And it is two better rate. One is language, the other is homework. So we call this multi-better rate. Okay, multiple. So when we want to analyze this, we click here. General linear model, multivariate, okay? Why we use the multivariate? Because we want to analyze these two. If we just search one, we use unirate. Now we just search two, okay? We use multivariate and put this division here. Okay. Yeah. No need to take care about it. Just get the result. Okay. Position, okay, yeah, and then general model multivariate, and we put these two there, and we just choose some option, okay, and then we got the result. We got the table here, okay. This table is a multivariate test, and there are many methods to calculate F value. And you can see, no matter what method we calculate, the F value is almost the same, right? But usually we use in our paper, I will suggest you use this Weeks lambda, okay? The result shows Weeks lambda, this is what we call lambda. The result showed Weeks standard is 0.491, okay, value here. And the F value is 4.141, oh, that's okay. P value is 0. This is the most important because it is larger than 0.05, okay, it's larger than a significant level. So what? No significant, non-significant. Non-significant, that means the intelligence of this student is similar to the average adult intelligence. Yeah, students, their skill is 10. Yeah, okay? And the third, also listed in the table, Fiera, Hotel, Lane, multivariate significance, any people, any statistics scientists, they calculated the same FL value, right? Yeah. So don't care about it. Yeah. If you want to write in your paper, you no need to write everyone. Yeah. The reviewer, you will suggest, he will suggest you delete someone. You just use one to represent. But usually we use the weak standard, okay? Because weak standard value is more representative. But here, I will give you this value. What is Bartlett's test of severity? What is mean? ANOVA is testing about the mean, right? So our hypothesis is mu1 equal to mu2 equal to mu3 equal to maybe mu n, right? Because ANOVA is testing about more than 3 population mean, right? And the NT is blah, blah, blah. Actually, before we're doing this, we have to confirm our data is coming from the same population or not, or their variance is equal or not. That means, before we're doing that, we have to confirm one thing. One thing. Their variance will be equal. Their variance will be equal or not. Before you're doing this, you have to confirm this. If the variance, the comparison of the variance among the population is equal, okay? There will be no problem to doing this. If you H1 holds, I mean the variance of among the population is not equal, oh my God, your data has some problem. Why? Variance is what kind of it? Variance is deviation. Variance is error. What is variance? I give you an example. For example, there are 3 school students. 3 school students, all they are primary school students, first year, okay? And if we want to compare the head of the students among the 3 schools, okay? And then the teacher will ask every student come here to measure their head, right? Come here, oh, measure your head, okay, 170, okay, measure. But when we are doing the measurement, first, A school, B school, C school. A school student always stand on a chair. The chair is so high. Okay. This is an A school student. So I will get his head. Your height, right? Oh, but they always stand on a chair so high. And the other student, the B school student, they are stand on here. Also stand on a platform, but the platform, the head of the platform is lower. Go, this one. No platform. Yeah, it stand on the flat. Yeah, here. Do you think, is it fair? Not fair, right? Unfair. Why? Because his head always includes this. His head always includes this. Right? Yeah, not standard. Why not standard? Because they always include some variance. This is a variance. This is a variance. This is a variance. So variance A is not equal to variance B, is not variance B equals C. Unfair. So the measurement, the data of the measurement is no use because they include some noise. Some noise in here cannot compare. So I have to tell you, if you want to do the ANOVA before, you had better make sure this one. If you got the variance is equal, congratulations, you will be greater. Yeah, if you got this, if you are confused, oh my God. Sometimes you will go to the laboratory to discuss with the teacher, and your teacher, I don't know why. Confused. Yeah, because the variance is quite different, you know. Oh, it's so high. It's no. So you cannot doing this. Yeah. So this is you say that validity. Yeah. So significant 0.55. Okay, just passed, just over. So that means the variance is equal. So you can do in this, no problem. Understand? But when as we can see, L1, L2. L1 is a language. L2 is homework. So L1 is no significant. Remember here, this table is consider with two scales together. But if we separate two analysis, L2 is significantly different. What do you mean? If we consider with two scales, language and the homework together, the young people is the same, is similar to the adult. But we separate. If we separate, we just one by one, we compare with language is similar, no significant difference. But if we compare with the young man and the adult with the homework, okay, it's different, quite different. And we doing the t-test. Minus. Okay, what do you mean? Adult minus young people is negative. Negative and up to significantly level. So we can make a conclusion. Okay? The intelligence of these students are not different from the adults in terms of language perform. In turn, first. But in terms of the performance of homework, oh my God, it's significantly different. Understand? Sometimes difference in the performance of homework. That means the young man is more skillful in working the homework because you are younger. Yeah, you have more ability. I'm old to die, too old to die. I'm lazy. Yeah, when I was young, yeah, I can overnight, I can sleep maybe for 1 day, 2 days, right? But right now, 1 day, tomorrow I will be almost dying, right? Yeah. So yeah, yeah. So yeah, yeah. ANOVA is research for all the variable. Research for all the variable. If we find this, you can go ahead, take a step. If you are a hypothesis H0, no need to do anything, right? But if you find, oh, H1 holds, you can take more steps to do your research. You understand? Yeah. Here, not always not equal. Some is equal, some is not equal. Okay? About the independent sample, okay? ANOVA. Independent. Independent, just as I ever mentioned, independent is separate. We doing some experiment or some treatment at a different place, different, we separate, okay, separately. So when you got the data from independent sample, ANOVA, how to do that? For example, the following table shows the scores of 10 students in experimental group. This is the experimental group. This is the control group. Experimental group, that means you give the students some training. Control group, that means you do nothing. Understand? Do nothing. We just as the usual. Experiment, that means you give in some treatment, or giving some skill, or some teaching, or anything. Okay? The student here has 10 students. Here has 8 students. 10 and 8. This 10 student is quite different than the 8. Okay? For example, U3 and U3, not the same person. Right? This is separate. Okay, maybe experimental student, I give them some training, so their score in English, grammar, reading, listening, comprehension, maybe is higher. I expect we are higher than this. Okay, so this is a what? Independent. And the 3, 1, 2, 3. 3 means, so independent 3, independent ANOVA. And you can say multivariate ANOVA. Yeah, I give them only one training, but the 3 results, Y1, Y2, Y3, Y1, Y2, Y3. So it's multivariate. Okay, how the results? Okay, So we can do that, yeah. Experiment is equal, experiment not equal to control, okay? Then, yeah, I do the SPSS for you. Here, grammar, reading, listening. Did you remember last time when we doing the independent t-test, I always warning you, not only the data, but also you have to edit one field. The field is group, right? Yeah, you have to define the data is belong to what group, right? So here, 111 is the first group. First group is the student under the experimental, right? The second group is the student under the control, right? And I also suggest you had better, when you key in the data here, you have to define the value. Yeah, 1 is where? Okay. Yeah, multi-value, right? Why multi? 3, Y1, Y2, Y3. Y1 is grammar. Y2 is the reading ability. Y3 is the listening comprehension. Okay. So put this back. Grammar, reading, listening, and the fixed factor is the independent variable, but group. Okay. Okay. Watch my PPT. I already doing the I already processed the process of the SPSS. Okay, I do it again. Sorry. Yeah, here. Okay, and then sometimes you can choose the poster hoc. What is the poster hoc? ANOVA, right? If the H1 holds, right, that means the mean of the population is different. Yeah, right? But what is the best? What is the better? What is the best? Bad, okay? Who will be the champion, right? Who is the first? Who is the second? Who is the third? We have to do in the comparison after ANOVA. If the ANOVA H1 holds, if we want to compare who is the best, we can choose the post hoc. Here, here, only two groups. One group is experiment, the other group is control. So two groups cannot do in the post hoc. If you want to do the post hoc, at least you have the three population, or more than three. Because the output data will tell you who is the best. The other will be the other will be bad. If your group is more than three, you have to choose the post hoc. But the post hoc, there are many methods. If I put this, they will turn on the light. There are many methods. We usually use is the LSD method. The second we use is Ch.4. But sometimes when you read in the paper, you always find many authors that use Tukey. Right? Even use the Duncan. Even use the Tukey speed. Okay, this is your assignment. Tell me what condition you use the LSD. What kind of the condition you use the this or Ch.4? When you use the Tukey, when you use the Duncan? It's very hard. Because in our example, we only have the two groups, so we don't need to do in the post hoc. If we have the three or more than three population, or three or more than three mean, we have to do in the post hoc. Okay, but there are many methods to help us to do the post hoc, but they all have some assumption. They must have some assumption or limitation. Can you help me to find out the limitation? Can. Wow, good. I like Uncle. Uncle is very good. He's brave. Good. Yeah. Can you tell me? Go home to find. Yeah. Usually, in your paper, I will suggest you. In paper, I will suggest you use the Ch.4 and the Tukey. Yeah, usually use this. LSD is too rough. Too rough. I usually use this. But when we use the Duncan, go home to find it. But here we don't need, because there are only two groups. So we just OK, press OK. And I will explain what it means. Okay, seeing here, okay. The first we got the multivariate, multiple test. And then we got the Weak standard. Multivariate ANOVA table, okay, and then we got the value of the weak standard. Weak standard is 0.374, and the F value is 7.8. 7.8. The significance is 0.03. Very small. It is less than 0.05 significant level. That means what? I told you, ANOVA is looking all the variables. Okay, not only one, not only two, all the variable. All the variable tell me if they are sibling, you know, brother and together. Oh, you every day you fight together. Not a good boy and a good girl. So it's quite different. Yeah. Okay. Sibling in the family. All the children is quite different. Okay. So you have to go more, take advance to analyze other. Okay. Oh, when you here the second of the between subject effect. We only have two groups, but have three results. According to grammar's score, the F is 3.5, but the P value is 0.7, non-significantly. But about the reading and the listening, reading, no. Listening, it is 0.02. It is very similar to Taiwanese English teacher. In Taiwan, our senior high school or junior high school, sometimes we hire foreign teacher, especially from America, to enhance, to promote, improve our student ability. But finally, students just they improve their listening comprehension, but grammar, reading, no. Because the teacher not teaching the student grammar and reading. But Taiwanese English teacher, they always focus on the grammar and the reading. But our English ability is so low. Because the student always confused with the grammar when they start to learning the English. This is very similar. Yeah. So they don't, in their brain, in their mind, they don't remember too much vocabulary. So they cannot speak. For example, I want to talk with you. We go to the line market, we go to eat some snack, and here is a noodle, beef noodle, everywhere. I can introduce everything, but Taiwanese student cannot tell that. Yeah. Just like this, grammar, reading, not improve. But here, so this teacher should come from America. Yeah. The student listening comprehension will improve, but nothing improve. Yeah. No, just the example. I give you random. Okay, time is short. The dependent variable, dependent sample ANOVA. I will ask the Miss Sari to give you the data. You go home to practice by yourself. Yeah, it's similar to the t-test. But finally, I will taught you again. I hope that everyone, you have to learn or practice how to make the conclusion. It's more important to play the software, okay? What kind of the table, the value, you have, what value you have to use in your paper. And you use this paper, how do you make the conclusion is more important. Okay? For example, the result showed the F value of the test effective item between the subject are 3.57, 53.006, and another. Okay? Respectively. In paper, we use this very much, respectivity. Okay? Not among, no. respectively, not separately, no. We usually use respectively, okay? Yes, if you want to submit the paper, you have to talk about the paper's English. You understand? Respectively. And the p-value are blah, 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 respectively. So there is no difference in performance in item in terms of performance, but there is a significant difference in the performance of listening, which show that the performance of the experimental group is much better than the control group in listening. Only in listening. The other, then. Understand? Okay.
We report the F value in this example, but previous example, we didn't use
Yeah. What?
yes, this example, we write the F value as conclusion. But the previous example, we didn't use the F value. We use the
T test.
T value.
Yeah. Two populations, we use T. Three, we use F. ANOVA. But if you say, can I use F to test the two populations? Can. It's same. It's same. Okay? Any question? Oh, today's assignment is very hard. Please tell me what condition when the result, when the H1 holds, we making the post hard, what method, what condition we use? Use what method? LSD. Just tell me LSD, Ch.4, Duncan, Tukey. Only 4, okay? When we use this, okay? Can you make a comparison table or list to tell me? Okay? Here. Postcard. Yeah, what? The LSD, Ch.4, Tukey, Duncan. Okay, only these 4. The other I don't care. Okay, there are too many methods. But when you reading the paper, you usually read some author use this method. Why? If someday, in my experience, if you submit a paper over 2 paper is accepted. Sometimes the journal the editor will ask you to be the reviewer. Yeah, help them to review the paper. And sometimes if you become the reviewer, you read some paper, they use the statistical method and they use the Tukey. You can ask him why you use the Tukey, why you don't use the Ch.4. Okay. All right. Any question? No question. Yeah? Question? No? No question. 90. Okay. We will end our class. Thank you very much. Bye-bye.